What I'd like to do for a minute here is to take us back in time considerably further than the 1970s and to a time long ago when we had the ancient world here and people were looking to start congregating together and building cities and towns. And one of the things that really hampered the growth of most communities for many centuries and millennium was access to water. People were either by rivers or they had a well or they were carrying buckets or whatever it was they were doing. But the bottom line is, if they didn't have access to water, you didn't have very many people there. And most of the cities and civilizations were relatively small because of that. Well, something changed that, and that was the ability to start to manage that water. And there was one society that came up with a way to do that, and they literally changed the world. And they built an infrastructure that's still available today. So people didn't have to go to the small little wells or for the creek beds or anything else. They had the ability to go out and actually bring all the water to them over vast, great distances. And when they did that, they were able to build quite a civilization. And you look at these aqueducts, they're still there today. I don't know how many of you have seen them. I've seen them all over the Middle East and Europe, all the way down into Israel, all over Europe, where the Roman aqueducts were built, and many of them are even in use still today, where they transported water over hundreds of miles. And able to do that, they were able to build a city like had never been built before in the history of the world. Because if you didn't have access to enough water, or clean water, or the environment that would create that, they did not have the ability to create the civilization that they did. But if you look at this, the foundation of the Roman Empire came because of the Roman aqueduct system. If you look at this chart of population, and you look at the explosion of population growth around 100 AD when they really started building the aqueduct system, they were able to grow to a city of over 1 million people from a couple 100,000 in a pretty short period of time, when really, again, most people were living in really small little towns with virtually no access to the water that they needed in order to function. So we wonder, what does this have to do with 2G, 3G, 4G, 5G, 6G, and whatever other G we want to talk about? Well, it has everything to do with it, because what's happening with the IoT ecosystem is access to the water. Everybody goes, well, everybody keeps showing the hockey stick. The hockey stick is always a year or two away. The hockey stick is right around the corner. We're going to see this massive growth. But what hasn't been there is the ability to support the massive growth. You haven't had the right components in the ecosystem. And part of that is the water, which is the connectivity that makes it all work, that gets to them cheap, reasonable, over long distances, and allows them to be able to support the devices here. And these are just things that are coming out of different reports from Deloitte. Consumers are slow to connect with IoT. The Internet of Things is too confusing. We've all heard these things over and over. The IoT growth has been slower than expected. What the IoT ecosystem needs is a change at the foundational level that will allow all these devices to be communicating in a way that they have not in the past. We need a big fat aqueduct that's going to make this work, and work in a way that people haven't seen before. Now, a lot of people say, oh, well, it's all about, I don't know about you who've been around a while. I was there when 2G was launched. I was there when 3G was launched. I was there when 4G was launched, and it was the answer to world peace. I mean, LTE was the answer to everything. And now what are we talking about? Well, LTE isn't really the answer to everything. We need LTE-M, or we need NB-IoT, or we need whatever else is going to come in the alphabet soup next, because really it doesn't really do what we want it to do. So what we get with this network evolution is the challenge of new technologies that come out, but they don't have the life expectancy of what we need. The Roman Empire was able to grow to this massive empire in an ancient world when most of the people in the world were living very substandard to what the Roman Empire had, because they had this aqueduct system and road system that worked throughout the entire empire for centuries. Centuries. We're talking about evolutions of cellular that last for 7, 8, 9 years. Wow, that's great. We need things that are going to be out there for decades and longer. Because if we don't, people are spending all this money on infrastructure, rolling trucks, deploying systems, deploying solutions, connecting devices, and then if they have to go out and roll a truck and start over, tear everything out, and do it again, it destroys the entire ROI of whatever it is they just built. That is one of the great challenges of IoT. And if you look at this chart here, when we started with analog devices that got sunsetted, 2G devices which are now being sunsetted, 3G devices which are getting sunsetted right after 2G, and that's the dirty little secret we don't know too much about. And now we're talking about 5G coming. We're refarming the spectrum on the cellular side from 2G and 3G so that we can do 4G and 5G. It's just the way it is. The cellular industry is built for human interface. That's a great thing, because we all have smartphones and we want more data and we want it faster, we want it bigger and better, and we can walk into a store and get a new device tomorrow. It's not a big deal. And it's okay, because this whole system and everything is built for humans to interface with machines. But when you start talking about IoT and machines interfacing with machines, it's a whole different ballgame. The machines can't run down to the store and replace themselves. When you have to send someone out to tear out the machine to put out a new one because your G just died, you've got a big problem. I was around when analog went away. I'll talk a little bit about what happened when that happened in a few minutes. But we are experiencing the 2G sunset as we speak, and like I said, 3G's right behind it. And if you look at this chart, it's going to keep happening. And each time it happens, you will have many more machines that gets stranded than were stranded the first time around. So, this is a auto assembly line. We're going to talk about OnStar. OnStar, phenomenal product. One of the first truly successful connected car products in the world. Great, great product, great user experience. Only one challenge. They were getting water from a river that they thought was going to flow forever. Someone dammed the river and took the water and put it somewhere else. First, they cut off analog. No big deal. Anybody know how many analog devices got stranded when we turned off analog in the wireless world? It's like 500,000 devices. Not the end of the world. 500,000. How many 2G devices were there when they started, just in the US alone, started setting 2G? 30 million. OnStar has millions that will go dark forever. The vehicles are going to be around for decades, but their river of communication water just dried up because they needed to reuse that water for something else. Again, it's not that the cellular guys are trying to be bad guys here. They're all about making you happy with the devices that you have in your pockets right now, because that's what it's about, that $80 ARPU device that's going to use multiple gigs a month. It's not about the infrastructure for the machines. So here they are stranded. Well, guess what? 3G is going to sunset. Now we're talking about over 100 million devices. And I got news for you. Eventually, 4G is going to sunset. It's the nature of the evolution of cellular and what is happening in that side. So what we need is we need to have a solution that really creates longevity and stability in this environment. And that's really what stopped it. Again, what stopped these cities from growing big is they couldn't get water, they couldn't get consistent water, and they couldn't get it for long periods of time. They didn't have the sources. Well, when Rome built the aqueducts, they built the sources. And they created the environment that allowed that to happen. You want to have hundreds of billions of machines? You have to change how you connect them. You can't do it the way it is today. As this slide says, consumer electronics drive a 5G world. That's what it's all about. We're talking about Band-Aids to help machines, whether it's Cat 0, Cat 1, Cat M, NB-IoT, whatever we want to call it, today, tomorrow, or the next day, those are all Band-Aids for machines to work on a human system. It's not the way it should be. The next thing that's coming is NB-IoT. It's going to be a great product. It's not here today. You hear guys talking about, oh, it's right around the corner, it's almost here. It's not here today. It doesn't exist, but that will be the latest flavor of the month for the cellular companies to be able to support your machines. But let's say we do have NB-IoT and it's out there and it's in the world today. What happens when you're running on that LTE backbone network? If you look at it from a network prioritization standpoint, How many of you been somewhere with your nice 4G device, and eventually it's going to be your nice 5G device, and you got 4 bars and you can't connect a call? You're in rush hour traffic, you got tons of traffic, everybody's on the network, you can't connect, you can't get through. Well, I got news for you. If you can't make a call on the phone in your hands, the machines aren't talking to each other either. And if you have critical infrastructure that needs to communicate, whether for financial reasons, safety reasons, whatever it is, they aren't communicating because that network is full and the prioritization is for those devices that we all hold in our hands. What you need is a network for machines that's designed from the ground up for machines that isn't going to be eclipsed by what's happening on the human side in that LTE backbone. So one of the other challenges that we face around the world is, again, it's too complicated. It's not easy to do business. You cannot create a global solution. One of those problems is because of all the different spectrum and radio frequencies around the world. If you want to create a solution today that's global and you want to have that device move throughout the world, you need 16 radios in it. Can you imagine building a small little device with 16 radios in it so that you can have a global solution? You can't. Besides the fact that you have to have all these different kinds of contracts with all these different carriers all over the world, regardless of roaming agreements and other things, it is a challenge and it's an expensive proposition. How would the world change if you could build one device with one radio in it, one antenna on it, and you could run it all over the world on one spectral frequency? That would be simple, or as we like to call it, simply genius, which is what Ingenu means. But that's what this industry needs to really change the world. That's one piece of it. There are other pieces as well. This is just a map showing what different spectrums of just the ISM bands are in the world, what the different frequencies are, and how complicated it is to try to get a global solution today. It's not easy. This business to become hundreds of billions of machines needs to get easy. It's the only way it's going to happen. We run our network on the 2.4 spectrum. Now people will go, why run it on 2.4? Isn't that unlicensed spectrum? Yes, it is unlicensed spectrum. And our network was designed from the ground up for machines to communicate in that spectrum. Why? It's the only spectrum that's available in every country on the planet. You can build one device and you can ship it anywhere, you can connect it to something and move it anywhere, deploy it anywhere. No matter what you do, it will work. And it's designed from the beginning to be in this spectrum that can be congested, can be interference. You've got Wi-Fi in there, you've got Bluetooth in there. People will say, you can't be successful in that spectrum. We have networks running all over the world today, every day, that deal with that interference in little areas that don't have a whole lot of devices like Los Angeles, Tokyo, Seoul, and a lot of rural areas too. But it works very, very well. And we have the patents that protect it that can support that because it's so unique. So am I here to just harp on LTE? No, LTE is going to cover a good segment of this business. You want video, you want high-speed data, you want diagnostics that create lots of bandwidth, lots of data analytics and so forth. You need to add voice into your solution for dispatch and things like that. LTE is your answer. That's not what we do. If you look at the world today, 86% of the machines that are deployed today use 3 megabytes of data a month or less. No video, no voice, 3 megabytes of data a month or less. That's what our RPMA technology supports today all over the world. So LTE has its place, and whatever is 5G, and we call that past NB-IoT, it will have a great place as well. But when there's ultimately 1 trillion machines out there, the vast majority of them are still going to be using small amounts of data. There will be applications that use a lot, but there will be many more applications that use considerably more. So RPMA stands for Random Phase Multiple Access. If you look at this first bullet here, and you talk about coverage and the capacity of devices, give you a couple stats. We have the network up and running in Phoenix. Like I said, we have networks all over the world, and we're covering the entire United States with our RPMA network. There are thousands of cellular towers in the Phoenix metropolitan area. We covered the entire area with 12 towers, with better coverage and in-building penetration than you can get with cellular coverage. We can get in the building, we can get in the basement, we can get underground meters. It works with RPMA, and it works today. Plus, the capacity of the number of devices, which is what this little chart shows, is significantly higher than what you can do with cellular on the same tower. So we have the ability, at a small fraction of the cost, to deploy a network that can support billions of machines, not only in the US, but all over the world. And again, it was engineered from the very first step to support machines. So things you don't think about when you're using your device in your hand become really important. If you drop a call or you don't connect, you know it. You're on your phone, right? But if you're sending a message to a machine, you don't necessarily know that message has gotten through or not gotten through or been interfered with or dropped in congestion or whatever else has happened. So what do? We can acknowledge 100% of all the messages that are delivered, of all that data traffic. You do not get that with a cellular network on NB-IoT. The other part here is, this is a list. If you look on the right, those are all the bands you got to have to cover NB-IoT globally. Again, for us, it's one band in the world, so it simplifies that, and cost perspective is pretty important as well. Behind the scenes firmware updates. We have a channel for firmware, for downloads. You got uplink and you got downlink. If you don't have both, your device is dumb, okay? So people who are saying you can build a network that you only have uplink, you don't need downlink, I got to tell you, I've been in this industry for 15 years. I have supported tens of thousands of products in 71 countries. I've never seen an application that didn't require a downlink, ever. Why you would want that network, I don't understand, but the bottom line is you need to be able to communicate with the device, even if only to change the time of day or how often you want to get the data out of the device. But you need to have that, especially for firmware updates as well. And you don't get interruptions during peak usage, because you don't have interference from all of us guys on our phones during that peak time, because the network is not used for that. The network is used specifically for machines. So another thing is battery life. We all know how great the batteries are on our phones, right? I've had a couple applications. Once I downloaded them, I had to delete them off my phone the next day, because all of a sudden I couldn't even make it through half a day with my charge. So we know what happens with the cellular. The cellular is about maximizing that speed and that data throughput that you're going to get. It's not about saving battery life. With an RPMA network, you can put a device on a container, ship that container all over the world, ping it every day, and the battery will work for 20 years. Not that's what we think it will do, or someday in theory it will do. They're out working today. These devices are working and deployed in the world today. And the fact that you don't have a sunset cycle, you know that that device is going to be there. We control the IP. We have 32 patents. No one can tell us we have to sunset our technology. We don't have some standards board creating the next standard that just killed our last standard. So we will give long-term network guarantees to companies that look for them. I've been a cellular guy for the vast majority of my career. We can't give long-term network guarantees on the cellular side because we don't control the future. There's too many other entities that have their hands in what the future will be. But we can do that with RPMA. So if you look at what's going on today, they are just in the point we hear of finalizing standards on NB-IoT. Now, I don't know about you, but if Huawei's running test networks in China using one standard, and Ericsson's running test networks in Europe using another standard, and in Korea they're running test networks using another standard, and now the US carriers are getting together to run test networks on another standard, I would venture to say they haven't finalized the standards yet. They're still in a contest to see whose IP gets into these systems faster than the other guys. So let's just assume the standards are ready. No one's built the chips yet. No one's building any devices yet. No one has the firmware software uploaded onto the towers yet, which is the theory on NB-IoT. No hardware on the towers. It's a firmware upgrade. But the bottom line is RPMA's here and ready to go. We rebranded our company from OnRamp to Ingenu at this conference a year ago. In the time of that 1 year, the wireless industry has talked about, if you look at the bottom there, Cat 0, Cat 1, LTE-M, LTE-M1, LTE-M2, and now NB-IoT. Every one of those standards have been discussed in the last 12 months. Some of them are already dead, some of them are still to come. Whatever is happening, it's destabilizing everything that's happening in IoT right when we're at an inflection point when it's growing like crazy. That's why we need a technology like RPMA that can truly change everything. So about a week and a half ago, ABI Research, great company, came out with a new research report. I ask everybody to go on the internet and download the full report from ABI Research. If we would have put this report about, no one would have believed it because it is so profoundly positive of what RPMA brings to the table versus any other technology that's either in existence today or being discussed about being in existence, like NB-IoT. But if you look across everything here, from bandwidth coverage, battery life, capacity, battery life, security, scalability, you name it, RPMA is the most predominant technology coming out of this report today and in the future, as far out as they can see in their analysis. So please go download that at ABI Research. Another loud voice in the industry is the gentleman who built Verizon as the CTO of Verizon, who's the guy that said LTE is the future of the world and got the entire world to follow his lead. He's the chairman of our board, and here's what he says. Oops, did we not get the video? Did that not come up? Hang on a second here. Why did that not play? Is there something you got to push over there? See what's going on over there, Max. Oh, here it comes.
Probably have to turn it up a little. This is Dick Lynch, the CTO of Verizon.
To somebody like myself, and they say, well, why did you get involved with Ingenu? What are they when you've got LTE? Here you are, one of the guys that pushed LTE on the world. Well, look, there's nothing wrong with LTE, and its performance is great. But on the other hand, RPMA is a technology that was purpose-built to handle Internet of Things. And my view is that I haven't seen anything like RPMA come along in any of that other alphabet soup. This is uniquely different, and it's uniquely different to the advantage of the end user customer. It's uniquely different to the network provider. And I think its advantage is it works, it's here today, and the people who need it can quickly understand the advantage it gives them. If you're looking for a low-cost, high-performance network that's purpose-built for things going on the internet, Ingenu is the place to look. And I think with the technology and the deployment strategy they've got, they win.
See, you got Dick Lynch, the CTO that built Verizon, Ivan Seidenberg, the CEO that built Verizon, Andrew Viterbi, the co-founder of Qualcomm and built our entire industry and invented the chip. Those three guys are on our board. And they're saying that RPMA is the future for machine communication. Pretty good validation of what the future's about. So we really truly are the foundation for IoT and the future of the Internet of Things. And I'm almost out of time, and I know you want to do questions. I got one last video though I got to get in there, so, and then we'll do the questions. But I'm gonna advance really quickly to this last video.
To meet growing demand for RPMA modules, Ingenu has partnered with U-Blox, a leading supplier of positioning and wireless semiconductors and modules for the automotive, industrial, and consumer markets. With facilities across the globe, U-Blox will put their expertise to work, designing and manufacturing new products supporting Ingenu's wireless RPMA technology. RPMA, or Random Phase Multiple Access, provides machines and devices with wireless, secure, two-way connectivity, operating in the universal 2.4 GHz wireless spectrum. the only frequency available for use in every country on the planet. Matched with the U-Block's form factor, which will enable customers to seamlessly upgrade wireless technology, single module global deployments will be easy and affordable. U-Block's an Ingenu. It's simply genius.
So we're partnering with some of the key players globally in this entire industry that believe RPMA is the future and are staking big investments on their side. U-Block's being one of them. We've had multiple announcements in the last 6 months. Key ecosystem providers that are getting behind RPMA because they believe we will be the global standard for machine communication. And I'll let you open it up for questions.
All right, who has questions for John? He just threw a lot at us, and we have an industry leader here on stage for the next 4 minutes, so please take advantage if you have any questions.
I guess we just covered it, so.
What's the number one question that you hear from people when they are first exposed to this technology?
It's funny because I spoke this morning at the Fierce Breakfast, and the very first question is this first question that always comes out, and it's, what about security? Is this secure? Well, we have networks running all over the world. Some of them are running utilities with nuclear power plants. It's secure. It's secure as any network that you've seen out there, and we have all the encryption that you would expect out of a network where you wanted to do any kind of transactions on it or have a very, very stable environment. So that usually is the first question that comes up, and I don't know if anybody has any others, but that's the most common one.
Do we have any other questions out there? Have you reached out to OnStar regarding how they can change their technology to keep up?
Well, we have pilots going all over the world with some of the largest world brands who are looking at a long-term stable solution for the first time ever, whether they're in automotive or shipping, transportation, all sorts of different segments that are really looking at this as the first true global solution they've ever seen. So I don't want to mention brands or names until the deals are done, but we do have pilots happening all over the world right now.